Let's look at differentiating trigonometric functions. First one, the simplest one, y is equal to sine of x. Okay. Now here straightforward difficult to figure out how to proceed. But remember, we always have the option of differentiating using first principles, right? So let's do that. So dy by dx is equal to limit as h approaches 0 of sine of x plus h minus the original function divided by h, right? So now limit as h approaches 0 of sine x plus h. So this can be written as sine of x cos of h plus cos of x sine of h minus sine x divided by h. Okay. Here we have sin x. So let's take common out. So limit as h approaches 0 of sine of x times cos of h minus 1 plus cos of x sine of h. And let's split this. So this becomes by x, this becomes by k. And now if we take the limit, what will happen? Here if you notice, as now let me write it separately, cos of h minus 1 by h, limit as h approaches 0. So here what will happen is, this would be equal to 0, and you can actually verify it by building a table of these values. Let me put that table and you can just have a look at it. Here if you notice, as h goes towards 0, cos of h goes towards 1. Cos of h minus 1 goes towards 0. So when you divide cos h minus 1 by h, the denominator, however small it gets, it still has some value. So what will happen is, when we divide it, it will go to 0. We can do it mathematically also, but we'll have to use something called as an Hopital rule. So that will come much later. Okay, so this is one limit that we need to know. Now another limit we need to know is limit as h approaches 0 of sine h by h is equal to 1. Okay, this also we can do something similar to this. Actually this I've already done in some other session, so you can have a look at that. Okay, so which means our limit becomes, here this becomes 0, this becomes 1. So which means what? Sin x times 0 is 0. So this limit will become 0 and we'll be left with only cos x. So the result is cos x. So dy by dx of sin x is cos x. Okay, let's look at the second one. Y is equal to cos x. So dy by dx is equal to, again to first principles, limit as h approaches 0 of cos of x plus h minus cos x divided by h. So this gives us limit as h approaches 0 of cos x plus h will be cos x times cos h minus sin x sin h minus cos x divided by h. Okay, now here we can rewrite this as limit as h approaches 0 of cos x times cos h minus 1 by h minus this would be sin x sin h by h. Okay, and we can take the limit separately. So here this will become 0 and this will become 1. So we are left with, and h has disappeared. So the limit is minus sine x. So dy by dx of cos x is minus sine x. So y is equal to sine 4x to the power of 5. Now we know what is the derivative of sine, and we know the chain rule. So dy by dx is equal to cos of 4x to the power of 5 times 5 fours 20x of 4, which gives us 20x4 times cos 4x5. Okay, fourth one, y is equal to sine of x to the power of 4. dy by dx is equal to sine is cos x to the power of 4 times 4x cubed, which gives us 4x cubed times cos x. Fifth one, y is equal to cos of 5x cubed. dy by dx is equal to cos is minus sine 5x cubed times 15x square. So the derivative is minus 15x square times sine of 5x cube. Okay, sixth one, y is equal to cos of 3x cube. dy by dx is equal to cos is minus sine 3x cube times 9x square. So minus 9x square times sine of 3x cube. Okay, seventh one, y is equal to cos of x to the power of 4. So dy by dx is equal to minus sine x to the power of 4 times 4x cube. So minus 4x cube times sine x to the power of, okay. Eighth one, y is equal to sec of x to the power of 5. Now, you don't have to remember, all the standard derivatives of all the trigonometric functions, because even if you don't remember it, very quickly you can do it. So instead of looking at x to the power of 5, first let's look at y is equal to sec x, right? Which can be written as 1 by cos x. Yes, and we know the quotient rule. So dy by dx is equal to cos x as it is. Then the derivative of the numerator, that is 1. It's a constant, so 0. Minus. Then the derivative of cos x, which is minus sine x, and the numerator as it is, divided by cos square x. So this becomes 0. Minus times minus is sine x by cos x times cos x, which gives us what? Tan x times, this is, remember, 1 by cos x. So 1 by cos x is sec x. So sec x, derivative of sec x is tan x sec x. So here it becomes very straightforward. We write tan of x to the power of 5 times sec of x to the power of 5, and then 5x to the power of 4. So 5x to the power of 4 tan x to the power of 5 sec x to the power of 5. Okay, ninth one, y is equal to cosec 4x cubed. Again, as I mentioned, you don't have to remember it, just do it on the fly. So cosec x is equal to 1 by sine. So dy by dx of 1 by sine x is sine x as it is, derivative of 1 is 0, minus derivative of sine x is cos x times 1, divided by sine square x, which gives us this is 0, minus cos x by sine x times sine x, which gives us what? which gives us minus cot x times 1 by sine is cosec x. So which means now the dy by dx here is going to be minus cot 4x cube times cosec 4x cube times 12x square. So the derivative is minus 12x square times this is cot 4x cube cosec 4x. So that was the ninth one. Now let's look at the 10th one. Y is equal to sec of 4x to the power of 5. So dy by dx is equal to, now we have already seen what is sec, what is the derivative of sec x. So based on that we can write tan of 4x to the power of 5 times sec of 4x to the power of 5 times 20x to the power of 4, which gives us 20x to the power of 4 tan 4x to the power of 5 and sec x 4x to the power of 5. Okay, 11th one. Y is equal to tan of 4x 4. Okay, now again let's take the simplest case. Y is equal to tan x, which can be written as sin x by cos x. And we can apply the quotient. Dy by dx is equal to cos x as it is, sin x is cos x minus uh, minus sin x divided by cos square x. Okay, so now this becomes cos square x minus into minus plus sin square x by cos square x, and this becomes 1 by cos square x, which is equal to 1 by cos square is sec, so sec square x. So derivative of tan x is sec square x. So dy by dx is equal to sec square 4x to the power of 4 times 16x cube. So the derivative is 16x cube sec square 4x to 4. Okay, 12th one. Y is equal to cosec 4x square. So dy by dx is equal to, now we already know what is cosec. Cosec is minus cot 4x square and cosec 4x square times 8x. So which gives us minus 8x cot of 4x square and cosec of 4x square. 13th one. Y is equal to sine cube of 3x cube. Again, don't panic, we can always write this as sine of 3x cube to the power of 3, right? So we can apply the power rule first. So 3 sine 3x cube to the power of 2, 3 minus 1 2 times, now we have to do it for sine. So sine derivative is cos 3x cube, and finally we have to take care of 3x cube, so that gives us 9x square. So the answer is 9 3 is 27x square sine square 3x cube cos 3x cube. Okay, 14th one. Y is equal to cot of cube root of 2x square plus 1. Again, we are encountering cot for the first time. So let's find the derivative of the simple cot x, which can be written as cos x by sin x. So the derivative will try to find it by using a quotient rule. So sine x as it is, cos x is minus sine x minus now sine x is cos x, right? Divided by sine square x, which gives us minus sine square x minus cos square x by sine square x, which gives us minus, if we take it out, we are left with sine square x plus cos square x, which is 1 by sine square x, which gives us minus cosec square x. So the derivative of cot x is minus cosec square x. So now here the dy by dx would be minus cosec, and here remember this can be written as cot of 2x square plus 1 to the power of 1 by 3. So here what do we have? Cosec of 2x square plus 1 to the power of 1 by 3. This applies to only 2x square plus 1. Okay, times. Now we have to do the power rule. So 1 by 3, 2x square plus 1 to the power of 1 by 3 minus 1. That is minus 2 by 3 times. Now the innermost. So 2x square plus 1. That is 4x, which gives us minus 4x times cosec 2x square plus 1 to the power of 1 by 3, and this is negative exponent, so that goes down, and here the 3 will also be down, so 2x square plus 1 to the power of 2 by 3. And if we have to write the answer in the form in which they had given in the question, we would write it as minus 4x cosec cube root of 2x square plus 1 divided by 3 times, this would be what? Cube root of 2x square plus 1 square. Okay, that is the 14th one. Now let's look at the 15th one. Y is equal to cos of square root of 4x square plus 3, which can be written as cos of 4x square plus 3 to the power of 1 by 2. So dy by dx is equal to, derivative of cos is minus sine 4x square plus 3 to the power of 1 by 2 times 1 by 2 times 4x square plus 3 the power of 1 by 2 minus 1, that is minus 1 times 8x. So here 2 4's. So our answer is going to be minus 4x times sine 4x square plus 3 to the power of 1 by 2, and this is negative exponent, so let's take it down. So 4x square plus 3 to the power of 1 by 2, or we can write it as minus 4x uh, sine of square root of 4x square plus 3 divided by square root of 4x square plus 3. Okay, so here the important thing is, make sure that you understand this 1 by 2 applies to 4x square plus 3 and not to cos. Okay, so that was 15th one. 16th. Y is equal to sine of cube root of x square plus 2. So dy by dx is equal to, sine is cos, so cos of cube root of x square plus 2 times, now we have to take care of the cube root, so 1 by 3 times x square plus 2 to the power of 1 by 3 minus 1. So 1 by 3 minus 1 is minus 2 by 3 times 2x. which gives us, uh, let's take 2 by 3 we have. So 2 will be in the numerator, 3 will be in the denominator. So 2x cos cube root of x square plus 2 by 3 times x square plus 2 to the power of 2 by 3. Or we can write it as cube root of x square plus 2 square. Okay, 17th one. Y is equal to cos of square root of x square plus minus 2. Okay, so again we can write this as cos of x square minus 2 to the power of 1 by. So dy by dx is equal to, cos is minus sine x square minus 2 to the power of 1 by 2 times 1 by 2 times x square minus 2 to the power of half minus 1, which is minus half, times 2x. So 2 and 2 cancels, and we have minus x sine x square minus 2 to the power of 1 by 2. This is negative exponent, so we bring it down. So x square minus 2 to the power of 1. And finally the 18th one. Y is equal to cube root of cosec of 2x cube. This can be written as cosec 2x cube to the power of 1 by 3. So dy by dx would be 1 by 3 cosec 2x cube to the power of 1 by 3 minus 1 is minus 2 by 3 times. Now, cosec is minus cosec 2x cube cot 2x cube. And finally, this 2x cube, that is 6x square, right? And this 3 and this 6 cancels, and we are left with, so we have minus here, 2 here. So this would be minus 2x square times. Here no exponents are negative. So let's write that. Cosec 2x cube cot 2x cube divided by cosec 2x cube 2 by 3. Now, actually, if we had thought a little bit, we could have done the simplification in the previous step itself. But anyhow, so if I take this up, because this is cosec 2x cube, this is also cosec 2x cube. So this will become 1 minus 2 by 3, which gives us minus 2x square cosec 2x cube, 3 minus 2. So 1 by 3 cot 2x cubed. So that is the derivative of trigonometric functions. That's it. Bye.